Good morning students. Today I am going to explain about the transistor as an amplifier. The basic application of transistor, we know the basic application of transistor, that is it acts as an amplifier. The transistor to act as an amplifier, it requires the emitter base junction must be forward bias and collector base junction must be reverse bias. That means the transistor should be operate in active mode. So today I am going to explain how the transistor acts as an amplifier. What type of voltages and resistance we have to give into the transistor. We know we have two types of transistors. One is NPN transistor and another one is PNP transistor. Out of these two transistors, we are considering in most of the applications NPN transistor. Why we are considering NPN transistor? The mobility of electrons is more than mobility of holes. That's why in most of the applications we are considering NPN transistor. So now to draw the transistor as an amplifier, I am taking NPN transistor in common base configuration. NPN transistor in common base configuration. So here base is the common to both input and output. This is one is emitter. I am taking NPN transistor. So positive, the arrowhead goes from positive to negative, and here I am applying forward bias because the transistor, to work the transistor as an amplifier, it should be connected in active mode. For that purpose, I am applying forward bias between emitter base junction. So this terminal is emitter, base and collector. So here emitter is the negative, so negative terminal of the battery is connected to emitter with respect to positive. So base is positive. So emitter is connected to negative terminal of the battery with respect to base. Here I am applying signal, and at the output side. At the output side, to take the output, I am connecting one resistor that is represented with RC, load resistor. Now I should provide forward bias, reverse bias at the collector junction. We know the transistor operates in active region, emitter base junction must be forward bias and collector base junction must be reverse bias. To connect the collector base at the between collector and base junctions negative, so connect positive terminal of the battery to the collector with respect to base, and this voltage is known as VCC and this voltage is known as VEE, and the voltage between these two is called VBE, and the voltage between collector and base is called VCB. So here I am applying the input signal. Initially I am not applying any signal, that means any AC signal. So at that case the currents, input current IE equal to 0 and Vin also 0. Now I am applying voltage, input voltage, sine wave, 0.1 millivolts sine wave applying to the transistor. So at that time there is a change in the input voltage. That change is represented with delta Vin. So that is 0.1 volt. 0.1 millivolts. So if there is a change in the input voltage, that change produces change in the input current. The directions of the currents are, here the emitter current flows away from the transistor, that is represented with I, and input current flows into the transistor, that is represented with IB, and the collector current also flows into the transistor, that is represented with IC. So a small change in the input voltage produces a change in the input current. So here the input current is also 1 milliamps. So it produces 1 milliamps input current. If there is a change in the input current, that change will create some change in the output current. So there is a change in the output current. That means it produces some current at the output current. So IC is also equal to 1 milliamps. Here the function of transistor is, if you are giving any voltage at the input signal, the corresponding voltage creates a small change in the input current. If the small change at the input current creates a large change in the output current, and the corresponding current produces the output signal. Here we are taking output voltage across the load resistor, that is V0 equal to load resistor V0 equal to, we are taking across the load resistor, that is RC into IC. Here I am taking output 5 kilo ohms. We know that for a transistor, the input resistance is very low, but output resistance is very high. So that's why we are considering output voltage 5 kilo ohms. Now substitute the 5 kilo ohms resistance in the given equation. Then 5 into 1 milli kilo ohms, that means substitute the value 10 to the power of 3 into 10 to the power of minus 3. Both are get cancelled. Now you are getting 5 volts. So V0 equal to 5 volts. V0 equal to 5 volts. Actually we are giving 0.1 volt, 0.1 millivolts input at the input side of the transistor, but that 0.1 millivolt is amplified by the transistor to a required level. So we are choosing the transistor as per our requirement. If I want 1 volt only, at that time I am taking resistance, output resistance is 1 kilo ohms. If I want more voltage, that means if I want 10 volts, at that time I am taking resistance 10 kilo ohms. So, and the resistance should be beyond the typical values. We know the output resistance, it is in the range of kilo ohms only. So nearly up to 100 kilo ohms we have to take to amplify the input signal. If I am giving low input signal, if I am taking high resistance, at that time also the resistance the output signal will be high. So depending on the resistor value and providing the voltages, biasing voltages, we know the first and the foremost condition is it should be operated in the active region. To operate the transistor in active region, emitter base junction must be forward bias and collector base junction must be reverse bias. If you are not applying the forward bias at the emitter base junction, if you are applying reverse bias at the collector base junction, that means if you are applying reverse bias also here, at that time the transistor, both are in reverse biased condition, at that time the transistor, the signal of the transistor goes into the cutoff region. So there is no amplification in the signal. If you are applying, both are forward biased, at that time the transistor signal goes into the saturation region. So there is no amplification. At that conditions, the transistor acts as a switch. We know the different regions of the transistor. That is, if the emitter base junction is forward, both the junctions are forward biased, at that time the transistor operates in the saturation region. If the transistor operates in saturation region, the output is, what is the value of output? It is acts like a closed switch. So the function of transistor in saturation region is it acts as open switch only. It can't be works as an amplifier. So to work the transistor as an amplifier, we should provide proper biasing and we should connect the required resistance. That means if you want output voltage 5 volts, like that you have to connect the resistance. If you want 10 volts, like that you have to connect the output voltage. So that is these are the factors affecting the transistor as an amplifier. So to the transistor works as an amplifier, we should provide two factors. One is we should connect the transistor in active mode of operation. That means emitter base junction must be forward bias and collector base junction must be reverse bias. And another one is the output resistance should be high and the input resistance should be low. Here we are taking very low input signal. That means sine wave signal. If you can take voice signal also. So that low signal is amplified by the transistor to 5 volts. At the output we are getting output voltage. So here we are getting amplified output signal like that. That is 5 volts. So the output of the transistor is 5 volts. This is the amplified version of the input signal. Here we are applying only it is 0.1 millivolts. So it is amplified the input signal. It is amplified by the transistor to a required level, that is 5 volts. So this is the transistor acts as an amplifier. Thank you.